In the second week of this first chapter, we need to learn about the forces between multiple charges because we have already learned about the Coulomb's law. Okay. So if there are more charges, then we need to find the force on any charge due to all the other charges. For example, if we have Q1 here, Q2 is at a distance of R12, Q3 is at a distance of R13. Okay. So what is the force on 1 due to 2? This will be equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square R12 cap. This will be acting along this direction because both are Q1, Q2 are both positive. So it will repel. Same is the case with force on 1 due to 3. That will be equal to 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 square R13 cap. Since again both are positive, it will be repelling. So basically we are finding the force on Q1 due to Q2 and Q3. So we need to take the vector addition. We need to complete the parallelogram and the diagonal will give you the resultant force on 1. So this is called as principle of superposition. The total force will be the sum of the force due to the other two charges. Now the next concept is, this is the third concept in the chapter, that is electric field. Electric field is, if you keep any charge Q, around the charge, there is a region where this charge can exert a force. And that charge, we call it as the source charge. And the force is always tested by a test charge. And the test charge is always 1 Coulomb positive charge. So, in short, we can say that the electric field is defined as the force experienced per charge. So, we can write the formula as, if, for example, if we have the force between capital Q and the test charge Q, you will have the force as 1 by 4 pi epsilon 0 Q small q by R square. This is divided by a Q, so we get it as only capital Q on top. So what is the expression for electric field is 1 by 4 pi epsilon 0 Q divided by R square. That means only the source charge will come. SI unit is force per Coulomb. So Newton per Coulomb, or in next chapter, we will learn it as volt per meter. Now the dimension of electric field is force divided by charge. So ml t raised to minus 2 is the force. Charge Q is equal to IT. So you'll get it as AT. So this will be the dimension for electric field. Same as that of force, field also, vectorially, it will get added up. So each time, wherever I need to find the electric field, I need to keep a test charge there. And we know that test charge is 1 Coulomb positive charge. If it is Q1, this test charge will be repelled. Q2 also repelled. E2. Okay. But depending upon the distance, more distance means less will be the field. So we need to find the resultant of that. With respect to E1, 2, we are taking the third charge, E3. Now, based on this, again, you need to complete the parallelogram and you will get what is the total electric field at 1 due to 2 and 3. The only difference between force and electric field is, if it is force, it is equal to 1 by 4 pi epsilon 0. There will be two charges, Q divided by R square. But if it's electric field, it's only 1 by 4 pi epsilon 0, just Q divided by R square, where Q is the source charge. Now, electric field, vectorially it will add it up. Then, electric field lines are imaginary lines along which a positive charge would move if it is allowed to do so. And tangent at any point will give you the direction of the electric field. These are the common field line representation. If it is a positive charge, it will be moving away from it. If it is negative charge, all the field lines will come towards. And this is two positive charges, they repel. A dipole, it will attract. Dipole is a combination of a positive and negative charge kept at a short distance. So the properties are they start from positive and end at negative. And the charge, in a charge-free region, the electric field lines are continuous curve. That is, there is no break. And two field lines can never cross each other or they do not intersect each other, because if they do so, there will be two tangents, that is two direction, which is not possible. And they do not form any closed loop. Basically, magnetic field lines are closed loops. Now, the fourth electric quantity we need to learn is electric dipole. It's a pair of equal and opposite charges. So, the force between them, we call it as the dipole moment. And dipole moment is measured as one of the charge into perpendicular distance. Charge unit is coulomb and distance is meter. So, please write the C big. Otherwise, we will read it as centimeter. SI unit of dipole moment is coulomb meter. That is also a vector quantity, and the direction of this is from negative to positive. Negative to positive. And what will be the dimension? Dimension of charge is equal to A into T times the distance. That means L. So LAT is the dimension for dipole moment. Now what we need to do is two derivations are coming up here. One is the field on the axial point of a dipole. Field on the axial point of a dipole, we need to take the dipole minus q plus q at a distance of r. I need to find the point P. So at point P, if we need to find the field, I need to keep a test charge. And we will see this test charge is repelled by plus q. So we will get it as it is repelling. Okay. But that is more close to point P. So it will be of longer distance. But E due to minus Q is far. So the field will be also less. So the net field at P will be towards the right. This will be the net field. And the net field and the dipole moment vector. You know, dipole moment is from negative to positive. So field and dipole will be in the same direction. Now we will see the direction of the field is clear now. Now we need to go for the magnitude of that field. So field due to plus q is 1 by 4 pi epsilon 0 q divided by. I need it only till here. Therefore, this much is r. So r minus a will come for the plus q charge. And for the minus q, it will be minus q divided by r plus a the whole square. So we will get the total field. Total field is equal to E due to plus Q plus E due to minus Q. Take the LCM. So R square minus A square the whole square. Cross multiply R plus A the whole square minus R minus A the whole square. Expanding R square and A square will go. You will get only 2 times 2AR. Now we all know that Q into 2A is P. So P into 1, 2 is already there. 2 into R. 2PR divided by this much we will get. Now we take the assumption that R is much, much greater than A. So if R is much, much greater than A square raised to the whole square is neglected. So R square raised to whole square is R raised to 4, which will get cancelled with 1 R on top. So you'll get only R cube. So this is the field due to dipole on the axial point. It will be 2p times by 4 pi epsilon 0 r cube. But when we are considering the equatorial point means it is a perpendicular bisector. So there we will get in the first one, if it is a plus q, it will be repelling. If it is a minus q, it will be attracting. But these two lengths should be equal. Because X, it is equidistant. The point P is equidistant from the dipole. So you will get E due to plus Q as E due to plus Q will be equal to 1 by 4 pi epsilon 0 Q divided by X square. And E due to minus Q is also 1 by 4 pi epsilon 0. Either you can put it as minus Q or actually we are considering the direction. It is attracting. Okay, so this will come as Q divided by X square. That means the magnitude is the same. So if the magnitude is the same, I am going to resolve this into two components. One is the sine component and one is the cos component. Okay. And it is seen that the cos component will only exist. The sine component will get cancelled because it is acting in opposite direction. See, magnitudes are equal, directions are as shown in the diagram, and the components normal to the dipole cancel away. That is, the sine component will cancel and the cos component will get added up. So what is the total electric field? E due to plus Q plus E due to minus Q. Here in the textbook, they have written it with respect to P. Just check that electric field is from left to right. But the dipole moment is in the opposite direction. So 2 times EQ cos theta is the magnitude. 2 times EQ cos theta is the magnitude, but it is opposite to the dipole moment. Opposite to the dipole moment. So what we get is 2 times 1 by 4 pi epsilon 0 q divided by x square into cos theta. And what is cos theta? Cos theta is equal to a divided by x. This is the theta. So adjacent side divided by hypotenuse will give us the cos theta. So you'll get that as a by x. Now you replace it for x cube. X cube will become r square plus a square whole raised to 3 by 2. And the same assumption, r is much, much greater than a. So a term will get cancelled. So r square raised to 3 by 2, 2 will get cancelled and you will get only r cube. So always remember children, E axial is equal to 2p divided by 4 pi epsilon 0 r cube, and that is along the dipole moment vector. And E equatorial is equal to, instead of 2, minus p divided by 4 pi epsilon 0 r cube p vector. So two things you can understand is E axial is equal to 2 times E equatorial. Magnitude is 2 times. And E axial is equal to minus of E equatorial in direction. So what is the angle between E axial and E equatorial is 180 degree because that is acting in the opposite direction. So these are the two derivations we have covered in the last week.